A strategy that I'm introducing here, I multiplied the right side by sine theta over sine theta. That made my denominator sine theta times 1 plus cos theta. If I multiplied this side by 1 plus cos theta, top and bottom, I'm multiplying by 1 again. Can you see that at least I make my denominators the same? And that gets it a little bit closer. So this strategy, I give this strategy a name. I named it myself. I call it build the other side. You multiply by 1 to make something on both sides the same. In this case, I make both of my denominators the same. And then I look, well, what would happen when I multiply out the tops? And again, we have a difference of squares here. Can you see that it's factored 1 plus cos, 1 minus cos? If you multiply that out, you're going to get 1 minus cos squared. So now my denominators are the same. I just have to come up with a way that I can make sine squared equal to 1 minus cos squared. And now that they're squared, we can go to our identity and say, hey, I can use sine squared plus cos squared equals 1, because 1 minus cos squared is just sine squared. And we're done. Now, sometimes this strategy is called multiplying by the conjugate, because what we did on the left-hand side was we multiplied 1 minus cos theta by 1 plus cos theta. So sometimes it's called that. I find that many of you have forgotten what the word conjugate means in mathematics. Did that ring a bell when I said conjugate? No. So in a difference of squares, we call a binomial where one has a plus and the other one has a minus. Those are conjugates in math. And because that's a word you don't use very often and you don't remember easily, the whole strategy of multiplying by the conjugate, a lot of people forget it because they forget even what the word is. So I renamed it build the other side because that seems really easy to think about. If I can make my denominators the same, then maybe my numerators will end up being the same. And that's what happens in this situation. So this too is an advanced strategy. Here's another one. If we change things to sine and cos and get a single fraction, on the right-hand side we do not have a single fraction. So we need to get a common denominator. What would that common denominator be? Well, it would be 1 plus cos and 1 minus cos. So I would need to multiply top and bottom. And then I have a common denominator, which is 1 plus cos times 1 minus cos. What does that do? That's a difference of squares. So I could just multiply it out. So that difference of squares comes up a fair bit. And I multiply that out, and I get 1 minus cos squared as my common denominator. On the top, can you see that I'm going to get 1 plus cos theta plus a 1 minus cos theta? I'll write it out. Do we have any like terms? We do. 1 plus 1 is 2. Cos minus cos is 0. So we get 2 over 1 minus cos squared. Now, with the 2 cosecant squared, we talked about this before. I see people doing the same error that we tried to talk about before happening again. Remember, the error is that 2, people are tempted to bring that to the bottom of the fraction. Because cosecant squared is 1 over sine squared. So the temptation, since you're doing 1 over, is to bring the 2 down to the bottom as well. But if you take an extra step and say, I'm just going to change cosecant squared to 1 over sine squared, and there's a 2 out in front, then you have to ask yourself, Does that 2 multiply just the top? Does it multiply just the bottom? Does it multiply them both? Right? And if you think of 2 as 2 over 1 and think about what's my rule for multiplying fraction, it just multiplies the top. So now I've got 2 over sine squared and 2 over 1 minus cos squared. And I've done the main strategy of change things to sine and cos and get a single fraction on both sides. They're still not the same, so now we have to start looking at some other strategies, but maybe you're starting to really recognize, hey, 1 minus cos squared, that's my sine squared plus cos squared equals 1. 1 minus cos squared is sine squared. So I have these new strategies and old strategies all summarized on a page for you. So on page 620, I think you have a blank page in your booklet. Okay. I'm going to put a number 1 beside those 2. That's our number 1 strategy. Get a single fraction combined to sine and cos. I'm going to put a red dot beside those 2 because they're basically the same strategy, just written in different ways. And I am going to put, since these ones are the same, I'm going to put a green asterisk beside those ones, because if you use the number 1 strategy and you get stuck, it most likely means you have to either factor or build the other side to finish your proof.